Okay, so hey, I mean, we're continuing to just plug away, right? And let's kind of look at this idea again, a continued growth around division as equal groups. But this is kind of like part two, right? This is the return part two. So we kind of worked earlier with this idea of like, okay, well, if I have a problem, like this, actually, let's even make it a little, yeah, no, let's do this. This is good. I can see where this can go. So we have a problem like 20 divided by 4, right? So we're going to take and we're going to draw out, let's get another color in here. Looking too monotone. So we're going to draw out 4 circles. And then, right, we're going to distribute. This is what we talked about in the last video. So let's see, I can just go 1, 2, 3, 4. And I want to get to 20 with the same amount in each circle. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18, 19, 20. And as I count, I will see each circle has the same. It has 5, and that's my answer. It's the amount in one of the circles. When all the circles have the same amount, it's that same amount, right? So that's kind of what we looked at. But today, this part 2, this continuation, I want to talk about like what happens when our numbers get larger, right? The process isn't going to change. Like, we're not going to change what we've been doing. What we've been doing is working, right? So you have 4 groups that you're putting 120 into. I guess we'll stick this one right here. We have these 4 groups, and now we're going to distribute 120. And like, yes, you're right. 1, 2, 3, 4. I could sit here and do that, right? I could count out all the way to 120, but I'm going to be here a long time doing so. So now we start to just step it up a little bit and thinking about the idea, well, again, if we're using these groups, we really are just like skip counting, right? We're using how this concept of counting and skip counting works. And in this case, it's not really skip counting because we're counting by ones. But what if we start to take chunks of groups with numbers that we like skip counting with? Like, I can skip count by 2s. So that like helps me. It's a lot quicker. I can skip count by 5s. That helps me. It's a lot quicker. And I can skip count by 10s, right? These are probably the most common numbers I skip count by. 2, 4, 6, 8, 10, 12, right? 5, 10, 15, 20, 25, 30, 10, 20, 30, 40, 50, 60. Like, we've been practicing how to skip count these numbers. And why this is so helpful is because now instead of just counting by 1, we can skip count and put those amounts into our circles to allow this process to feel easier to manage, if you will, right? So I don't know, let's just start with something. I'm gonna see, let's get another color, and then let's just, I don't know, let's skip count by 10s first. So notice this time, instead of putting in the slash lines like we've done before, I'm just gonna literally write in 10 because that's a group of 10. So there's 10 in there already. So if there's 10 in that circle, I gotta put 10 in this circle, and 10 in this circle, and 10 in this circle. And let's see, does that work? 10, 20, 30, 40. Great, that works. All right, well, let's just keep going with another group of 10. And what I'm gonna do is I'm gonna put a little plus symbol in between them, because remember, I have to add them all up anyway, so that's gonna help me. So 10, 20, 30, 40, 50, 60, 70, 80. Okay. Let's do another 80, 90, 100, 110, 120. Oh, that worked out really well right away. So as you can see, I have 3 groups of 10 in each circle. So all my circles are the same, and that's what I want, right? And so then my answer is like, what is the amount in one of those circles, the amount they all have? And I see it's 10, 20, and 30. So this is like this same idea of equal groups, but as you can see, like as you can really see, I'm thinking about how I can skip count to help process this. So I don't know, let's do a larger, even larger one. Let's do 384. Oh my gosh, that's really big. Okay, and let's divide that by 4. Okay, this might be a lot. Let's see what happens. Let's just break this apart. I love it when we just make up problems on the spot and see what happens. All right, let's go with some color change to mix it up. So we know we're going with 4 circles. 1, 2, 3, 4. Okay, and then we can think about like numbers that we skip count by, right? We can skip count by 2s and fours, what? Fives, tens. It'll just be a good start there. I could skip count by hundreds, but yeah. Let's see what else. Oh, you know, if I can skip count by twos, I can skip count by 20s, right? Because that's just adding a 0, 2, 4, 6, 8, or 20, 40, 60, 80. All right, so I don't know, let's play around with that and see what we get. I'm gonna start with the 20s. I like that. So let's go 20, 40, 60, 80. Okay, let's do another one. 100, 120, 140, 160. Okay, this is getting hard for me to manage, so I'm going to jump to groups of 10. So 20, 40, 60, 80, 100, 120, 140, 160, 70, 80, 190, 200. Okay, so now you can see this is really building up. So I'm at 200. I'm going to go back to, now that I'm at 200, right? It's like a nice rounded 200 number. I'm going to go back to groups of 20. So 220, 240, 260, 280. I'm going to do tens again. 290, 300, 310, 320, 330, 340, 350, 360. Well, my circles need to be bigger. I'm gonna note where I'm at. I'm at 360 right now. I'm actually going to make some larger circles. Looks like I'm running out of space. So as you can see, like this is part of that process when we're doing our math. Sometimes this needs to happen. No biggie. I'm not even stressed about this. As you can see, I did note on the side of my paper where I'm at so far, so I don't lose track of what I'm doing during all this awesome work. But we definitely should make these circles a lot larger. So we have space. Okay. All right, so I was at 360. Oh, I'm pretty close, actually. I didn't even realize that. 360, we're only going to 384. So let's see, 360. If I did another group of 10s, 370. Let's try that with a different color so you can see my thinking. So another group of 10, so that'd be 370, 380, 390, 400. So like that wouldn't work, right? That would not work because I'd go too high. So let's get rid of those 10s. They don't belong in there. And let's think, what else could I skip count? We're at 360. 10s didn't work. Let's do a 5 and see what happens. Let's see, 365, 370, 375, 380. Oh, and then we can just do one. 381, 382, 383, and 384. Whew, wow, that was a lot, but you can see, like, this worked. Like, we could do this. It took some organization. I had to stop and think, but it works. And I have the same amount in each circle. Now I just need to add up all that's in my circle. So let's see here. Figure this one out. We got 20, 40, 60, 70, 80, 90, 95, 96. So my answer is 96. Wow, that was big. I like that, though. I'm glad that happened. I'm glad we had to change our circles. We had to make a little note on the side. I think that's some pretty good modeling of what to do. Maybe we won't be so extreme this time. Maybe let's just say we'll have 121. Let's get crazy. What do you want to divide this one by? Let's divide it by 11. All right, so now, again, this is why I did this, because I want you to see, like, again, we don't want to get discouraged by these numbers, the larger numbers, right? This is an 11. That just means I need 11 circles, which is a lot. I agree, but it doesn't mean we can't do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, and then we can skip count by numbers, right? we want to get to 500, but we could skip count by 5s or 10s or 2s, right? Let's see, let's do 10s first. Let's see what we get. Let's change colors for what we're skip counting with. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Oh, that's good. Okay. I'm gonna count by ones now just because I have so many. We'll see where we're at. So 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121. Wow, that's actually a really good example about how, like, when you first look, 121 and 11, it can feel overwhelming. But look at that. We knocked it out in 2 steps. We skip counted by 10s, and then we just did it by ones. And everyone has the same amount. Every circle has the same amount. So if you count that, that's 10 and 11. So our answer is 11. So 121 divided by 11 equals 11, which is the same thing. If we think about our multiplication, 11 times 11 equals 121. There we go. We just learned a math fact. 11 times 11, 121. 121 divided by 11, 11. Anyway, okay, so this is, again, that idea of like how we can use this idea of equal groups, right, to solve larger division problems in the idea of skip counting. Right, we're taking larger groups away first because, as I said, there is definitely a comfortability with us. Like we can count by ones, 1, 2, 3, 4, 5, 6, 7. We can skip count by 2s, 2, 4, 6, 8, 10, 12. We like to skip count by 3 or 5s, 5, 10, 15, 20. 10s. If it gets really big, we could skip count by hundreds. And we could also just skip count by other numbers if you're comfortable with it, right? These are the most common ones, but you know, if you're comfortable with it, you could skip count by 3s. 3, 6, 9, 12. I personally find that a little more difficult, but hey, whatever your brain works for your brains, right? 4, 8, 12, 16. So these are other options you could use just to keep in mind. But again, think about the difference of like when you can count by ones and when you should skip count by these larger groups when using equal groups to solve division. We will continue to work with division and quotients, so don't worry. Keep up the great work. Ask questions as needed. As always, I thank you for your time.